All right, so hello everyone, and we're going to continue our conversation about naming functional groups. So we obviously didn't get to this in class, so I wanted to make sure you had a video to watch later, and that way you can review it if you need to. But really quick, I want to get us sort of back in the zone since I know it's probably been a minute since you saw this stuff. All right, so remember today that we were talking about naming functional groups in general, like priority functional groups. So we talked about alcohols and amines, we talked about alkenes and alkynes, and all of those we said are priority functional groups. And that means a couple things. It means that they get to have the lowest number. If there's a choice, then you have to focus the lowest number on the priority functional group, and then you can do the other ones. And also that means that they get to have like last names. They get to have names that are at the end. Now, the one we didn't do today in class was ethers. Ethers are a new functional group for us, but they're not a priority functional group. Even though they look really special, they're actually not that special. So they're going to be equal priority with alkyl halides, which we did last time, and alkanes. So not too special. So we're basically going to be doing the old way of naming things. It's just there's a couple rules I want to make sure you know, and then I just want to review it, trying to put everything together. So remember with the priority functional groups, we talked about taking the pieces and the longest chain like we normally do, and then adding the endings. We'll go back and review that also. Okay, so let's get started talking about ethers. So just like we did with the other functional groups, so this is number 4, then for ethers, we're going to talk about what you do with them. So again, the most important thing about them is they're not a priority functional group. They don't get to have the special last name. They don't get to have special numbering. They're just like a substituent. Treat like a substituent, okay? Write that down. We'll say always. Okay, so for these, what you're going to do is you're going to keep the longest chain just like you normally would, but then the shorter carbon side is going to be just like a carbon prefix, all right? So you're going to have, if I have an ether, so let's look at an example. I'll put it down here. And maybe I'll switch colors. Okay, so let's use that one. So we're going to take the shorter side is going to be part of the substituent. Shorter side of carbons. We're going to use that number of carbon prefix, like meth, eth, whatever. And then we're going to take that and we're going to remove the YL and add an oxy. Okay. And then whenever we do the numbering, you're just going to do the, we'll say locant, right? The numbering, the locants. So just number it like a normal substituent. Okay, so we'll do an example. All right, so for number 9, what we would do is take the longest chain. So that's going to be for this one 4. This way 1, 2, 3, 4. Right, this side only has 1, 2, 3. So that's shorter. So undo. All right, so that means that's going to be the longest chain. So that's going to be carbon 4, which is butane. Like that. Then we're going to circle the substituents. So we're going to circle the oxygen and then all the carbons on it. And that part's going to be the substituent part, the ether part. Okay, so it says to use the carbon prefix. So that's 3, so that's going to be prop. And then instead of using YL, we're going to use the oxy. So it'd be propoxy. And then everything else is just going to be normal. So the next thing we would do is that's all the substituents. We got the longest chain. So we're going to do the numbers. 1, 2, 3, 4 makes sense, right? It's not going to go the other direction. So we'll put a 2 there. And then you would alphabetize it, put it in the front, do all the things you would normally do for a regular substituent. So, and put it in the front of the name. All right, so this would be 2-propoxy because it's the only substituent, so it gets to go first. And then you just put the carbon chain, butane. So a lot of times what people want to do with ethers is try to make them be like an amine. So remember we saw amines before. I'll switch this up. Sorry. Amines are different, right? Amines, you find the amine with the nitrogen, and then if there's a substituent on the nitrogen, you say N, right? Like N-propyl. This is N-propyl butane, right? But that's because that's a priority functional group that you do it that way. For these, don't put O-propyl because that's not going to be right. Instead, you just put propoxy, and that's the whole thing. Okay, so not like amines. Very important because people really want them to be like amines. Like amines. So there's no O as a locant. Don't do that. Just use the number of the carbon, and then the O is included because it's already included in the oxy. Okay, just to clarify. All right, let's do another example just to make sure that we feel good about the ethers before we move on. Okay, so we'll do example 10. All right, so for this one, let's do a ring. There we go. All right, so I'll give you a minute. You can pause the video if you want to, and then name this molecule. Okay, so I'm going to go ahead and get started. Hopefully you got it if you're unpaused. All right, so we know we have 4, so that's going to be C4. So that's going to be cyclobutyl this time, cyclobutane. We've got, I see a substituent that's an ene, that's a functional group, right? So that's going to be the ene. Then we have some substituents. We have a methyl, and we have a methoxy. That's this guy, right? So this one's methyl. And this one's meth because it's got 1 carbon. And then oxy because it's an ether group. Okay? And then we'll do the numbers. So let's see. Does anything have priority on here? Right, it's going to be the ene. The ene has a priority because it's a priority functional group, right, on this list. There it is. So that has priority, so that gets the lowest number. So I'm either going to go 1, 2, 3, 4, or I could start on the other side of the double bond, right? I could go 1, 2, 3, 4. Doesn't really help me. It's better to start with 1 because there's already a substituent here. So that's going to be better because I get a better set of numbers. So if I had used this set of numbers with the orange, I would have gotten, obviously, the alkenes 1, but then the substituent is 2, and the oxy is 4, right? Whereas if I use the red numbers, I get 1, 1, and then I get 3. So that's the better set of numbers. Both of them have to have the 1, right? The functional group has to have 1. It has to be the lowest number, right? But then the other two, the 1, 3 is obviously better. Okay, so I'm going to put those numbers on here. Maybe I'll erase that because it's getting a little crowded. Excuse me. Okay, so this is going to be 1. This methyl is going to be 1. And this methoxy is going to be 3. And then I will alphabetize them. So they both start with M. So then that means that if we go all the way to the end, the O comes before Y. So I'll do that one first. So it'll be 3 methoxy, 1 methyl, cyclobute. And then remember, I have to take off the ane and add an ene. And then I have to put the number, right? So it'll be 1 ene. All right, and that would be the name. 3 methoxy, 1 methyl, cyclobute, 1 ene. Okay? Hopefully that makes sense. If you have any questions, you can email me, right?